Hey everyone, welcome back to Learn with W3 Schools. Today we are diving into the world of Rust programming and we are going to learn in just 1 hour the all basic fundamentals of Rust programming language. I'm Professor Dr. Zishan Bhatti and for the last 19 years I have had the pleasure of teaching programming to students just like you. I'm really excited to guide you through this journey. Now, you might be thinking that Rust in just 1 hour, is this even possible? Well, the short answer is yes. We are going to make it fun, fast, and a super effective tutorial using W3Schools website. We will be using the awesome W3Schools website Rust tutorial as our roadmap. We will walk through the entire site together and I will break down all the core concepts, making sure everything is clear and crystal. By the end of this hour, you will have a solid grasp of Rust fundamentals, including variables, data types, ownership, borrowing, control and flow functions, and how to use struts and enums to build more complex programs. So, are you ready to code along and build something amazing? Let's start coding. Okay, so let's begin with Rust. Now, Rust is a popular programming language used to build everything from web servers to game engines. Rust is known for very fast and it's similar to C and C++ language, but it is quite fast. So the examples we're going to follow are going to be using the W3Schools own examples, using their own editor. We're going to go through each of these examples and try to explain what's happening within each code. We'll try it and then run it on as we go. Okay, so now let's see what is the Rust itself. Now, introduction to Rust. What exactly is Rust? Rust is a modern programming language. It is designed to perform reliability, safety, especially safe in handling of a memory. Okay, that's the key features and the key reasons why Rust is becoming so popular nowadays. Why we need to learn Rust? Well, it is one of the most fastest growing programming languages in the world. Learning Rust makes it easier to pick up other languages like Java, Python, C++, or C# because the syntax is quite similar. Or if you're coming from Java or Python or C++ or C#, learning Rust is much easier because again, the syntax is quite similar. So if you have done any of these languages, you would find that, hey, Rust is quite easy to learn. It is very fast comparing to other languages. It requires less memory compared to other languages as well. It is used to build web servers, creating games, operating system, and much more. So that's why you can now see that why learning Rust is so important in 2025, because it's fast, it has a similar syntax, and it requires less memory. Okay. Now, the difference between Rust and other languages. So if you look into it, the difference between Rust and C or C++, the main difference is that Rust is safe by default. That's the key feature that we're going to talk about, and all of these content we're going to go through. This is where it talks about. In Rust, memory access is automatically checked by a compiler, which helps to avoid common bugs, crashes, leaks, and unsafe memory behavior. In C and C++, you manually manage memory, which can lead to errors if you're not very careful. Okay, so let's get started with Rust and see how the basics work. Okay, getting started with Rust. At W3Schools, you can try Rust without installing anything. Okay, so you can just go inside the W3Schools default editor, which we will be using, and you can start practicing Rust right away in their own editor. However, if you do prefer to install Rust, you can install Rust with very different ways. Using, again, follow these steps. You can also install Rust in your VS Code, which I will show you in a complete different tutorial. So do follow. I will leave the link in the description below. But mostly for this tutorial, we're just going to follow the default W3Schools own editor. Okay, so now let's begin with the syntax. Well, how do we write Rust? What is a typical Rust syntax? So you have already seen the following code a couple of times in the first chapter. Let's break it down to understand it better. What's happening here is that we are now creating a function called main. Now, main is the default function. Now, this also note that if you're coming from C++ or C language, we do not write the word fn. We write the return type void. Here, there's no return type, just fn word, which is indicating that we are creating a main function, bracket star, bracket close, and then the println statement. Okay, so the fn main is something that always appears at the beginning of every Rust program. The main is called a function. These round parentheses indicate that it's a function. It is, by definition, a function is what we call a block of code that performs a specific task. It has a curly bracket start and curly bracket close, which is called a block of code, indicating the function block starts here and a function block ends here. The println line is a macro. In Rust, we call them macros. They are used to print text on your screen. In our example, the hello world will be printed on the screen. Let's see and execute this code. So if you click on try it yourself, you will see that the hello world is printed. Obviously, you can go and change the string here as well. Click on run again and it will run. Now this is called a macro. We will talk about these macros a little bit more, but do note there's an exclamation mark here, which indicates this is a macro, not a standard function. So what exactly are macros? Macros are like functions, but with an exclamation mark. Okay, so don't worry about terminology right now. For now, we're just going to go and understand what macros are, and we're going to talk a little bit more about how macros work and what exactly they do later on in these sections. Good to know is that Rust compiler ignores white spaces. Okay, so the main code above could be also be written as function main space, function main bracket block star, and you can write it on the single line and end it on the single line. This would still work perfectly fine. However, multiple lines and annotations make code much more easy to read, understand, and then follow along. So do always make sure that you practice giving new lines and new comments. So now let's talk about this output. How do we generate output in Rust? Well, in Rust, the output is basically means that we generate something on the console, give a print output on the console. And as talked in previous session, println semicolon is basically used to generate output on the screen. Okay, they are known as macros because of this semicolon here. They are type of function, but they work a little bit differently. Now, when we execute the code again to see how the output goes, again we use a function. So everything as we talked about has to be inside the function body, block start, block close, and we write print hello world. Similarly, you can write your own code as well. Print ln usually stands for new line. Oops, let me just clear the caps lock. Print ln exclamation mark bracket start bracket close semicolon. Now because we are writing a string, hello W3Schools. Okay, so what this basically means, because we're writing a string, every string has to be inside an inverted quotation marks. So if you run the code now, you will notice that it will print this next line as well. So you can have as many print lines as many print statements as you want, as long as they all follow the standard syntax. That is, you write println, you write exclamation mark to indicate it's a macro, bracket start bracket close with a semicolon ending the statement. This semicolon indicates it's an end of statement. Then because we are using a string, we are using within the inverted quotation marks and we get the output. Notice also the output is on a new line by default. However, we did not add a new line here. But whenever we write this ln, ln indicates new line. So print ln automatically has a new line. So every time you use print ln, the output will always be on a new line. Got it? Perfect. Moving forward. So now you can use as many times as we want. Println just talks about the same thing. So we have in this case 3 different statements. So if I click on the execute now, you see the output. So now we have 3 different println macros. Hello world, I'm learning Rust. It is awesome. Okay, and then I can add 4th line as well. So I can say, hey, print ln exclamation mark bracket start bracket close, and because semicolon. It's important. It indicates the end of line. Inverted quotation marks because this is a string. And then I can say learn with W3Schools, the channel name. If you haven't subscribed, please do subscribe. And when you execute, basically it's going to print all 4 lines on new lines. So now we have statement. So parent line print statement you can write as many times as you want. Now the print macro. There is also a print itself colon macro, not without the ln. Okay, which is similar to println. The only difference is that it does not insert a new line. So remember, we just talked about the new line. So in this case, if I omit the new line on this last one, and I can use a simple print statement as well. And if I run the code now, what happens is that because we have removed the ln feature, this means that we are telling it that, hey, I don't want this to appear on a new line. So there's no new line here. To indicate because we have 3 lines. Oh, okay. So we have 3 lines here. And then now if I remove the ln from the previous line, it is awesome, and run the code again. So see this, it is awesome, and learn with W3Schools comes on a new line. Why is this on the new line? Because it indicates that after this statement, add a new line. So new line is actually added at the end of the statement. Now here's another thing. If I add a print ln semicolon bracket start bracket close and inverted quotations, and I say, hey, please subscribe. Done. So now we have added ln here. This would indicate that this line should appear on the new line. Okay, but if I run the code, you will notice that this does not appear on a new line. In fact, it just appears after the learn with W3Schools my channel name. Why new line was not added? Because this line only had a print. Okay, this line only has a print statement. So whenever you use ln, it means print the statement and after this add a new line. Okay, so actually the new line is added afterwards. So that is why we have it is awesome from this line here. Then we have learn with W3 schools from this second print statement, and because both are print statements, they both appear on the same line. The third line, even though has an ln, but now this print ln, because there's no ln here, no new line is added. Make sense? Perfect. Let's move forward. Now, adding new lines. So to add a new line, basically you can use \n as well. They are known as escape characters. These escape characters means that whenever you use a backslash, it indicates to the compiler that you are writing a special code. And then when you use n, it means a new line. Okay, so just like many other programming languages, you can use the new line character \n to break up the lines manually. So in this case, if I want them to appear on the new line, I can say \n, and then I can come here and I can say \n. So this means that after this statement is printed, add a new line. After this statement is printed, add a new line. However, you can add this as many times as you want. So I can say \n. So before this statement is printed, add a new line. Then after the learn \n, add another new line. After with, add another new line. So after every word, now we have added a backslash. So if I execute this code, now what you're going to see is that this line is going to appear on the new line because we have added a \n here and then \n here. So there should be two line spaces. Okay, so see this is two spaces here, one breaking here and one another gap here. So this is indicating, hey, I have a new line, then I need another new line, then I need another new line. So every time you use \n, it's adding on a new line. Perfect. The indentation is because there's a space here. Remember, it counts this space character. So this space character is actually giving that indentation output. So you can use \n as many times as you want within the printing the output statements. This makes more sense, right? Perfect. So let's talk more about what are comments in Rust. Now, like every other programming language, Rust also has comments. Comments are basically given using double backslash inside the Rust. So every time you want to comment down something, means code that you don't want to execute, a line that you don't want to execute, instructions, a description, anything that actually you don't want to execute, but you want there to be in the code for the developer, for your team, for your remembrance sake, what you're trying to do here, they are known as comments. Okay, and they are done using the double backslash. Okay, this is same as C++, as Java, as C# as well. So every programming language has it. Python, Rust as also has the same thing. This example uses this is what we call a single line comments. Okay, means that every time you use it, it's a single line comment. Anything after this is actually commented out. You can write this single line comments even after the statement as well. So this means execute the statement and then ignore everything afterwards. So anything that presides with after the double backslash, they are completely ignored. You can use multi-line comments as well. Multi-line comments start with \steric and ends with *. What do we mean by multi-line comments? Just assume that you have multiple lines of text that you want to put in your code for explanation purpose. So you don't want to use \, again and again. So what we do is we use \steric, indicating that anything that proceeds after it will be completely ignored until */ is executed. So these are how we use comments in our coding. Okay. Now let's talk more about variables. Okay, variables. Well, variables are basically containers that store data. Okay, so that's why we say variables are containers for storing data values like numbers and characters. Understand basically that whenever we use programming, we have to use data, right? That's the whole purpose. So we do not put the data directly in our memory. We put the data with respect to variable name in terms of talking programming, right? So whenever we're talking programming, we say that if I have a value called John, I don't want to directly use this John value, but I want to save it in a container called name so that I can refer to this value again and again and perform various different operations on this thing. That's what the variables are used for. Okay, they allow us to save a value and then refer it back again and again using the same variable name. So assumingly, you think that name is basically a container, okay, and then it has this value John. Now I can call this name variable 10 times and it will always call the value John. I can perform various different operations on this variable as well, like addition, like using string functions, reading the string data, so on and so forth. So it allows us to manage the data more efficiently. Second, this data is stored in a memory location, and then the name actually refers to this memory location that, hey, there's a memory location inside your RAM or ROM and it contains a value called John. This John now can be referred using this variable name. So instead of calling John again and again, we don't know where John is. So using this variable allows us to know the exact location in the memory as well. Obviously, we don't handle the memory ourselves. Rust handles this memory automatically. All we do is we use the let prefix, give it a name, and then put a value. So this let prefix is actually the way it defines a variable, or it knows that this is a variable. Means it's a container that holds this value name. Now, in order to use this variable, we use it in print statement, for example, just like this. What's happening now is that we have a println statement with a colon, semicolon, with exclamation mark indicating a macro. We use a string, but notice it has a curly brackets inside it, then comma, and then the variable name. These curly brackets indicate that this value of these two curly brackets will be replaced by a variable called name. Okay, so this is also known as a placeholder. It's like a placeholder that holds a place. It doesn't have a value. It's just like somebody holding the space. Hey, don't sit here. My friend's gonna come. So whenever the friend comes, the value of this variable will be actually replaced with this placeholder. Make sense? Let's execute this code and see an example in action. Here we go. So now we have a variable called name, and when we execute the code, you see this, my first name is, and the variable's value is actually printed here. So this placeholder actually is replaced by whatever information we have saved in this variable, which is name. Okay, make sense? Better. So what exactly is this round brackets or curly brackets? The Rust uses these curly brackets as a placeholder in println to show wherever the variable names are, just like what I said. So in the example above, you will see that my name is John is printed because this name is replaced with the variable name. Now you can use these placeholders wherever you want within the string. So for example, if you want to format a string, is that your name is and your age years old. Okay, so now what's happening is that I have two variables called name, and then I create another variable called age. Let name is equals to John, let age is equals to 30. So it says John is 30 years old, and I want to print the statement. If I execute the code, now you see it prints John is 30 years old. How is it? Does it know which variable's value to go? Well, actually, we use a placeholder, is another placeholder years old, comma, and then we put the placeholder variable's value. So we say name. So the sequence of this also matters. Because we have used name here first, the name will be replaced in this variable here. Okay. Similarly, if you use age first, the age will go in the first variable. So whatever is the sequence will be followed exactly the same way. So we have first placeholder, we have a second placeholder. The first value is name, so the name value will go inside the first placeholder, and the age value is the second variable will go inside the second variable's placeholder. Make sense? That's it. So this is how you can easily customize a string, replace it with a custom variables information inside a println statement. And when you print the output, the value is replaced and this output is printed. Okay. So using placeholder order, it's quite important. So whenever you use many placeholders, the value you pass are in the same order. So that's what I just said. So the order of these placeholders is quite important to ensure that how the order data is being printed. So because we use the placeholder first, this will be replaced with the first value. The second placeholder will be replaced with the second value. So here, the first placeholder was replaced with the first value. So if you swap the value, for example, age becomes the first variable. So in this previous example, where we had name and age here, but if I just copy this statement, Control C, come back here, Control V, and then now if I replace the variables order, so if I say age goes first, and then name goes second. Now if I execute the code, you will notice that the string is same, but the variables values are now replaced because it doesn't understand the string. It just understands the placeholder and the sequence of placeholder. So now the string is same, but this time 30 is John years old. So the variables values are replaced. So the order is quite important. Whatever you put first will be assigned to the first placeholder. Whatever you place second will be assigned to the second placeholder. That's how the Rust basically works. Variables values cannot be changed by default. So for example, if I come here and I say, hey, by default variables value within the Rust cannot be changed, but if you want to change it, it will generate error. So in this case, we have let x is equals to 5. Okay, so we assigned a number to a variable called x and we defined it as a let, which means that we're creating a variable. And now I want to change its value. This is 10, so this generates an error. Okay, why? And let's see the error, because we have not seen the error so far. So if you execute the code, you will notice it generates a long list of code. The key important point here is that they cannot assign twice to immutable variables. Okay, this basically means that the x is equals to 5. You have already assigned a value to a variable x. Now you are changing that value. The variables by default are immutable. Immutable means that once you assign it a value, you cannot change it. Okay, so it says cannot assign twice to the immutable variable. This is the error code E0384. The value is already assigned. Now you cannot replace it with a new value. This is how an error is generated inside the Rust. So if you go back to the code, so it says that you cannot do that. You need to be careful about that. However, if you do want to change it, if you want to change the value of a variable, you must use the MUT keyword, which makes it mutable or changeable. Okay, so whenever we're declaring a variable, we specify another prefix MUT, and then we declare a variable name is equals to 5. Then println before, and then we can change the value and then print it. Do note, if you're coming from C, C++, C Sharp, or Java or Python, by default, all the variables are mutable. Okay, by default, all the variables are mutable. So you don't need to use the MUT keyword. If you want to make them immutable, you use the keywords like in Java, we use the word final, okay, indicating that this variable is final, or we use constant keywords in other programming. But in the Rust programming language, by default, the variables are immutable, so you cannot change their values. To be able to change the values, you need to use a prefix called MUT, which makes it mutable, or in other words, changeable. So whenever we declare a variable let, MUT is again another prefix. So we now use two prefixes to indicate, hey, I'm going to change this variable's value later on. So if you execute the code, now you see before it was value 5, then you change the value to 10, and then if you reprint it, afterwards value becomes changeable, no problem. But again, if I remove the prefix MUT, now you cannot do that. Make sense? Perfect. Okay, so now let's talk more about data types. Data types. Well, unlike other programming languages, variables in Rust do not need to be declared with a specific type, such as string, text, integer, character, short, or so forth. This is similar in C or C++ or Java. They do need to declare the data type specifically. However, Rust differentiates from that. In Rust, you don't need to do that. More like Python actually as well. In Rust, you just need to use the word let. So whenever you use the word let, it automatically implicitly defines a data type based on the declaration you have. So if you declare it as an integer 5, this will automatically be considered as an integer. If you declare it as a decimal value, this will automatically be considered as a float type. If you define a character with a single apostrophes, this will be considered as a character. And if you just use true or false, this will automatically be considered as a Boolean. This is called an implicit casting or implicit assignment. So every data type in Rust is basically implicitly assigned to the variable. All you need to do is use the word let. However, it is possible to explicitly tell Rust what type of data you are using. So for example, you can use the I keyword prefixing the value. So in this case, I'm using let my num colon I32 is equals to 5. So this colon I32 syntax will tell it, hey, I'm using an integer. But you know, it's a cumbersome thing. And we try to avoid it since it does automatically everything for us. We don't need to do that. So this is a simpler version of defining a data, whereas this becomes a little complex sometimes and overwhelming for a new learner. But again, yes, this option is available. So we can say let my double colon F64, which basically means that we are defining a float value of 64-bit. 0.599 is the value, so this will automatically be considered as that. I32, I stands for integer and 32 bits. Character, for that we just use a character D, and then Boolean we use colon Boolean, and then string colon and str. So this and str will define that I am using a string variable data type. Okay, so we will learn more about this when you need to specify the type later in this tutorial. Either way, it's good to understand what different types basically are available within W3Schools or within the Rust. Okay, so the basic data type in Rust are divided into 4 main categories. We have numbers, the whole numbers and the decimal number I32 and F64. I again stands for integer 32-bit and F is for floating point 64-bit. We have characters, which is a single character, string and Boolean data types. Numbers are divided into 2 groups, integer and floating point values. So integer again basically means any single number such as minus 456 or 123 or whatever number you want to give, from negative to positive values. Okay, so you can define them as I32 is equals to 25, separated by colon age becomes a variable name, and then we use the let keyword again. In order to print this value or we use this age variable, we use the print colon as exclamation mark as a macro. We say age is, and then we use the placeholder double brackets comma age. Okay, so wherever is the placeholder, we have already talked about this, the age variable will be printed. Similarly, we use the floating value as well. So whatever the value we want to assign it to a variable, now you can use this variable to do whatever mathematical operations on it or perform any printing or whatever effects we want. Okay, so once we have a value inside a variable, now we can very easily use it. Again, do remember colon 64, it's not mandatory, you can skip this, but this indicates that this is a specifically follow floating point. Same goes with the character data type as well. So we use character char type to specify a single character, means only a single character is there. Whereas a string is different from character because character only contains one character, whereas a string contains multiple characters. So we use double quotation marks here. So double quotation marks indicate we are using a string data type, and if you want to explicitly specify it, again do ensure that you use colon after the variable name and then and str. This indicates that hey, we are using a string data type. For the Boolean, again it only holds either true or false value. So whenever we are using Boolean, it either contains true or false value alone. So when you specify colon, you just use the bool is equals to either true or false. Okay, and then again the same way you can print the Boolean variable is in your println statement using the placeholder and then comma the variable name. Okay, you can combine the data and mix different types in the same program as well. For example, we have let name is equals to John, we have let age is equal to 28, we have let admin is equal to false. Okay, so this means that this is a Boolean data type, this is an integer data type, this is a string, and you can say hey name a placeholder and the name variable will be printed. We can say println age, and age is printed at the placeholder, and then we can use the Boolean type to print the Boolean type. So you can see this, we have three different data types and we have used them in three different scenarios. We can use multiple data types, as many data types as you want within a program. Make sense? Perfect. Moving on, let's talk more about constants. Now, constants are variables used to store values that never change. Unlike regular variables, constants must be defined with the type, example I32 or character. So creating a constant, use the constant keyword followed by the name, the type and its value. Okay, so whenever we want to define a constant, we define it a variable name, colon and its value. This is a mandatory part. Constant have to have the data types. Now by constant we mean that once you declare its value, you cannot change it. Okay, so its values become absolutely constant. That's why we need to specify the data type as well. And notice that they have written in capital letters. Okay, so this is again a convention, not a mandatory thing, but it's a convention like a standard that whenever you're using a constant or final words or some variables that are supposed to contain a fixed value and they're not supposed to change, better to use a capital letters for that. Okay, so that's why you will find many programmers tend to use the same practice as well as a convention that whenever they declare a constant variables or final keywords or variables that are not supposed to change, they use a capital letters in their variable names. And then for Rust, you have to use a colon and I32 indicating a value. Constants must have a type. That's the key thing that you need to follow along. That's why we need to define the type. Okay, so you must write the type when creating a constant. You cannot let Rust guess the type when you're using the regular variables. Okay, so if you don't use the constant and the type, it creates a problem. So whenever you're using constant, do make sure you always specify type. So if you miss out the type, this will generate an error for us. Okay, now the naming rules, again as I mentioned already, that another thing about constant is that it considers good practice, not a mandatory rule, but it's a good practice to declare a variable with uppercase. It's a standard practice that we follow along. Okay, so how do we differentiate between a constant and a variable? Well, here's a quick comparison. Features can change, a constant no. For constant cannot change, yes, but if it is mutable. Variables also by default are immutable unless you provide them explicitly a mutable variable. Okay, so the type required in a constant, yes, you do need to have a type, but in variables it's an optional, you may or you may not use. Okay, let's move on to more interesting parts now of Rust called operators that allows us to work with various different operators within Rust. Now, operators are used to perform operations on values and variables. The Rust supports most common operators like arithmetic operators, assignment operators, comparison operators, and logical operators. Let me explain exactly what each operators are and what their function is. Well, arithmetic operators, as simple and self-explanatory as they are, anybody who has done mathematics up till this point will always know what a plus is, what a minus is, multiply, division, and the remainder operator. So all these operators actually work inside Rust. So you can do addition, subtraction, multiplication, division, and a remainder operator means when you divide, it will tell us what is the remainder instead of the answer. So this division gives answer. The remainder operator always gives us the remainder value. And then obviously you can use this in your expressions as well. So you define a function main. Remember, we have talked about this. You need a main function every time you would have worked with a Rust program. Then you define let add is equals to 5 plus 3, which basically means you're doing addition. Whatever the answer of this addition is will be assigned to the add operator or add variable. And then you use this add variable in your println statement to print the statement. Same goes for every single other arithmetic operations. So you can perform all the arithmetic operations on the variables as well as the data type directly as well. So you can easily say add and sub. So add plus sub, this means you're adding two variables. That all works perfectly fine. Next, assignment operator. Now, what assignment operators are used and how they are there? Assignment operator we have been using is equals to. So this is equals to is something that we have done here as well. 5 is equals to 5, add is equals to 5. Okay, so this means we are assigning the value of this expression to the variable add. This is called assignment operators. However, there are a few versions to that as well. This is something called plus equals to, minus equals to, multiply equals to, divide equals to, and same model equals to. They are also known as shorthand operator as well. What they basically mean is that we write x plus equals to 3. What this evaluates into is this thing. It means that take the value of x, add it to the 3, and then assign it back to the x. Okay, so you usually write an expression in this way where we mean that, hey, take the value of x, subtract it with 2, whatever is the answer of this expression, assign it back to the variable x. Okay, so we are actually updating the value of x. So instead of writing these 4 lines, you can easily do that with this shorthand assignment operator. You can say x minus equals to 2. So this basically means, hey, I'm subtracting the value of 2 from an x and then assigning answer back to the x, just like in this case. Same goes with the multiplication, division, and obviously the modulus as well. Okay, the way it works is that let's look at an example. We create a Rust function, bracket star, bracket close. We say let mutable. Again, mutable means that this variable's value can change. Do keep that in mind. X is equals to 10. So now we say print ln start x. So it's going to use the value 10. Then we say, hey, x plus 5. So now it means that take the current value of x, add 5 to it, and assign it back to the x. So now if you print the value of x, it's going to print 15. Perfect. Let's look at the code now. Okay, so check out the code. It's exactly the same thing. It starts with the 10, and then because we did x plus 5, it's 15 now. Okay, so because we did x plus 5, it means take the current value of x, which is 10, add 5 to it, and assign it back to x. So now once you print the value of x, its value is already updated. So, but if you do x minus equals to 2, this means take the current value of x, subtract it 2, and then assign it back to the x. And if you print it, it's going to print 13. So current value is 15. Subtract 2 from it, now it becomes 13. So notice the value of x is consistently changing because again we have done a mutable here. If you don't use mutable here, this cannot happen. This will give us an error that, hey, this is an immutable variable. Keep that thing in mind. So if you need to change the variable's value, make sure it is set to mutable. And this is how assignment operator basically works. Okay, then we have a comparison operator. Now these comparison operators are quite useful. We technically use them with if-else statements and looping statements. What comparison operators do is they compare the values with each other and then return either true or false. So instead of giving us a mathematical answer, they actually give us a logical answer, meaning whether the logic is true or the logic renders a false result. So the comparison operators are double equal to, not equal to, greater than, less than, greater than equal to, and less than equal to. What this basically indicates that if you use equal to operator, now this means we are checking the value, right? It's like a conditional comparison. It checks whether the value of 5 is equal to the value of 5. So basic the logic goes the left hand side is equal to the right hand side. So is the value of left hand side equals to the value of right hand side? If it is equal, the answer is true. If it's not equal, the answer will become false. Similarly, not equal to will does the reverse thing. 5 is not equal to 3. This becomes true. So if you use 5 here, then this condition becomes false because 5 is equals to 5. Because now we have 3, so this means it's not equal to. Greater than is quite simple. Value is bigger than the next value. Less than, value is smaller than the next value. So left hand side is less than right hand side. True. Yep. Similarly, greater than equal to means that it is bigger and equal to it. So it might be 5 to 5 or anything bigger than 5 will return true value for us. And the less than equal to similarly will say, hey, it's equal to and less than the value of the right hand side. So 3 is less than equal to 4. So becomes true because yes, 3 is less than 4. That's how we solve the expressions in terms of our comparison operators. Then we have a logical operators. Okay, so these logical operators are again used within if-else boundaries. They provide a double condition evaluation. So in previous example, you see they're just checking one single condition. A is equals to B, or B is not equal to A, or B is greater than, less than, so on and so forth. But at the certain situations, we need to evaluate two different expressions to come to a final conclusion. For that purpose, we use AND operator, OR operator, and a NOT operator. The way they work is, in this example it is clearly shown. We have a variable called logged in set to true. We have a variable called is admin set to false. So now we want to check in that whether user is logged in and is admin or not. Okay, so we say logged in and not equal to admin. Okay, so what this will do is it will check whether the user is a regular user or an admin user. So if you evaluate the expression and check out the code, you see the answer is true. Why it is true? Because the logged in is again a Boolean. So now remember, AND operator requires a Boolean. This can come from a comparison operator, or you can directly use a Boolean variable. So because this is true, so it's going to check this side is supposed to be true and the next side is also supposed to be true. Okay, so if the both sides are true, only then this will return a true result. Or basically needs any one of them to be true. So is logged in, okay, and or is admin. So this basically means that it checks both sides. If this is true or this is true, either one of them is true, this will render a true result. So in our case, logged in is because this logged in is true, so anyone has the access. It doesn't have to be an admin, even though it is fault, but they can still access it. Not logged in means that we are not using the not, so it will inverse the result. Not will inverse the result. Okay, so means if it's true, it will become false. If it's false, it will become true. That's why we use it here. So is admin is by default false, but because I've used a not here, this will become true. Okay, so this expression will become true, and hence this side is true, and then as right hand side and left hand side both become true, and gives us a true result. So for logical operators to work, you need a conditions on both sides. More about this in if-else statements. Now let's move on to Boolean types. Now, very often in programming, you will need a data type that can only have one or two values, like yes or no, on, off, or most commonly in programming, we use true and false terms. For the Rust, Boolean data type is used to store the true and false values. Boolean represents that either the value is either true or false. How do we create a Boolean variable? Well, it's very simple. We define any variable name, colon, bool. If you want to explicitly define, it's a type Boolean, and we use true. Okay. So is fishy taste, colon, Boolean, set to true. When you use the values and the placeholder, this is going to print true or false for us. So Booleans are quite simple and easy to use and easy to follow, just true and false wherever we want to use the comparison. So whenever we use comparison operators, again, the answer is always of type Boolean data type, representing either true or false value. Okay, we use Booleans within the if statements as well. We will talk about if statements in the next session. But if you use if true, bracket star, bracket close will indicate that if the value is true, then if body will execute, else if it's false, the control will go to else statement. I'm going to talk about this in a moment, right? So the Boolean variables is also required by if. Okay, so if is a conditional statement that requires a Boolean value to know that which block of code it needs to execute. So that's why Boolean operators are quite important in programming. More about this now. Let's begin with if else. This is where the logical comparison and the logical development of your coding begins. Okay, so all the knowledge we have used here, actually we start to now use into more advanced features such as if else, match, loops, for, functions, and so on and so forth. So this is where our logic building of programming begins. So what exactly are if else conditions? Well, if else conditions basically define conditional statements. Okay, they define a logic based on true and false. If a statement is true, then certain code will execute. Else, if the statement is false, then something else will execute. That's what basically if else allows us to do. To make a conditional decision which statements to execute based on certain given conditions. So here, when we use A is less than B, this is a conditional statement. This condition will result either true or false. So based on this condition, the if block will execute. Okay, so we use these 6 standard conditional statements to determine which block of if statement is supposed to execute. If A is less than B, A is less than equal to B, A is greater than B, A is greater than equal to B, A double equal to B, or not equal to B. These are conditions that we will use because all of them will basically give us true and false results. And if else statements require true and false. Okay, so the if is you specified a block of code to be executed if a condition is true. So whatever you write inside the if block will execute only if the condition given to it is true. Else specifies a block of code that's executed when the condition becomes false. That's the key thing here. So if we use if else together, if the statement is true, the condition block will execute. Similarly, if it's false, the if else block will execute. I will show you in a moment how it works. Similarly, we have something called else if, that again does that if the condition is false, in that case something else, another condition will be evaluated. This is sometimes called a nested else if statement as well. And then we have a fourth type called switch statement that only executes matching a specific case. Okay, so unlike other programming languages, like if else can be used as a statement or an expression to assign a value to a variable in Rust. See an example at the bottom, right? So now let's see how if statement syntax is given in Rust. Now in Rust, the if statement is written with if, condition, block start, block close, and a bunch of statements. So if this condition becomes true, only then this block of code will execute. If the condition is false, these lines inside the block of code are completely ignored. That's what the conditional statements allows us to do. Okay, so for example, if we have two variables like x is equals to 7 and y is equals to 5. Now we evaluate an expression. If x is greater than y, then what we're supposed to do is we are checking a condition here. If the condition becomes true, only in that case, the if body becomes executable. Okay, so if you look at the example, the x is greater than y, this statement is executed. Why? Because the x value is 7 and y value is 5. So x value is bigger than y, the condition becomes true. Because it becomes true, now this gets executed. If you change this to, for example, y becomes 15 now. So now y actually is bigger. And if I run the code, you would notice that nothing would happen and there would be no output on this statement because this statement becomes false now. And since this is false, x is 7, y is 15, so this condition becomes false. Hence, nothing is printed. This line gets completely ignored. That's what the conditional statements allows us to do. To check if the expression is true, only then the block of code will execute. Otherwise, nothing gets printed. This is completely ignored. Okay. So this is where else comes into play. So if the condition does become false, in that scenario, what should happen? So since we are ignoring this line, if the condition is false, in that case, the else statement will automatically execute and run the block. So if I execute this code, this is where else comes into play. So now you say, for example, age is 16. Okay, and we check the condition. If your age is greater than or equal to 18, only then we say you can vote. So this statement is there. But because age is 16, the condition becomes false. The if block is completely ignored. This print line is ignored by the compiler. It doesn't even execute. It doesn't even read it. Hence, in that case, now the else statement is executed and the line print you are too young to vote gets printed on the screen. Now also check the syntax of it. The way it works is that we use if, condition, block start, block close. Okay, so here the if blocks ends. After the block ends, then we write the else statement, block start and block close, and we write the print statement. Okay, so this is how it works. So if condition is true, the block of code, anything you write within these curly brackets gets executed. If the condition is false, everything that you written inside this block is completely ignored, and the control from this if condition goes to this else statement. And then the else also has a block of code. So and you can have 1 line or 10 lines here. Anything you write within the block of code will get executed in case this becomes false. Else, in other words, by default is always considered as true. So if this becomes false, only then this is true. In this case, for example, if I make it 26, right? So now what happens is that because this condition now is true, age is 26, greater than 18, hence the print statement will execute and everything below it, the else statement is now completely ignored. So this is where the logical decision making comes into play. We make, hey, if this is true, execute the right hand side. If it's false, execute the else statement on the left hand side. Okay, make sense? That's how if else statements tend to work. Using if as an expression, like we talked earlier. In Rust, if else can also be used as an expression. This means you can assign the result of a if to a variable as well. Now, this doesn't happen in Java or C Sharp or C++. If doesn't evaluate to an expression, it always checks a condition and executes. So, but in Rust, it executes as an expression as well. What do we mean by that? Let me show you an example. So here we can see that if I zoom into it a little bit, yep, I think that's better. So now what you can see is that let time is equals to 20. Let greeting is equals to if time is less than 18, bracket start, bracket close, and we just use good day. Now this is an example of an expression. What this basically means that if the condition becomes true, then assign this value to this variable greeting. Else assign this value to this variable greeting. That way, we can have a conditional expression that returns a value and can be used to print or assign to another variable. This is what we mean by an expression. Okay. In Rust, that's allowed. In the Rust, it's only within the Rust that you can do that. Okay. So what's happening now is that if the condition is true, instead of printing in the output or executing bunch of code, we are assigning this variable and returning it back to a greeting variable. So this value gets assigned to it. Else, if this condition is false, this goes here. Then you can use print statement after it to print the value of greeting outside the if block. Okay, so when using if as an expression, you must include as statement. That's another requirement, that if you are using an if statement with it as an expression, there has to be an else statement. So it knows at least one value will be assigned to the variable. Otherwise, if the condition is false, then nothing is assigned to the variable, and that creates a problem. So ensuring that there's an else, we always ensure that there's some value being assigned to the variable. Okay, that's why if else always go together whenever we are trying to use them as an expression. Okay, a simplified syntax. So if each block contains a single expression, you can write it in a shorter way. You can simply say if time is less than 18, on a single line we use bracket start, bracket close, good day, else bracket start, bracket close, good evening. Again, this is exactly same as above. It's just like in this case, in the previous example, the compiler of Rust actually ignores these new lines and spaces and brackets at all. Okay, so it doesn't matter if you write it if you break it down into a new line or we break it into a single line, doesn't really matter. So you can write the same expression on a single line as well. It will work exactly fine. Usually, as a good programming practice, we always break it down into multiple lines and give it proper indentation. It looks nice, but you can always write it in a single line as well to simplify and create a normal syntax. Okay, so now the value of if else must be the same type. Okay, the two pieces of the text or two numbers of an example must be of same type. So you can have string, but if you use integer as a second expression, now this will create a problem, because at one point it could have a string, at another point it could have an integer. This creates a problem, and that's where the error occurs. Okay, so the both types must be of type string or both must be of type integer. So data type for the both values, if you're using expressions, has to be same. Make sense? Perfect. Let's move on further and talk more about Rust match. Okay, so now what exactly is Rust match? Well, when you have many choices, using match is easier than writing a lots of if and else. So for example, if you have like 10 different choices or 7 different choices to make, if this happens, then go that, else if, else if, else if. So instead of writing a complicated if else nested structures, match allows us to do a very easy match with multiple similar conditions. Okay, so match is used to select one of many code blocks to be executed. Okay, the way it works is that we define, for example, the whole code from starting with the function main. As we know, everything starts with a function, block start, block close. We have a variable day is equals to 4. Then we use a match statement. Then we provided the variable day, which basically means that evaluate this variable's value, comparing it with this 1, 2, 3, 4, 5, 6, and 7. What this basically is doing is that it's now comparing equal to comparison, day equal to value of 1, day equal to value of 2, day equal to value of 3, day equal to value of 4, and when the value matches, it executes the statement that precedes the arrow function. So equal to arrow basically indicates that once this value matches, execute this block. Okay, this is similar to switch and case in other programming languages. So match allows us to do multiple comparisons equally within one single statement called match, and then you can use as many comparison as you want. And for example, if nothing matches, then there is an underscore equal to. This means that if no value is matched, the default statement will be executed on this case, which is the last else statement. So automatically you can see it simplifies the if else statements greatly. The way it works is that the match variable day is evaluated once. So this variable is evaluated once, and then the value of day variable is compared with the value of each branch. So we're calling it a branch. So this is evaluating a branch, this evaluating a branch. Each branch is ending with a comma, not a semicolon, because this is like a continuation of the statement. Okay, so we have a comma, we have a comma separated values, unlike other semicolon values. Each branch starts with a value, which is again this value, followed by a equal to greater than sign. Okay, if there is a match, associated block of code will be executed. So if it's a match, so anything that precedes this arrow function will execute. If nothing is matched, then the last statement is executed under the underscore one, which is called the default statement. Okay, that's how basically the works. Now you can use multiple matches with the if else statement as well, which is equivalent to or operator. What happening now is that if you have a variable and you want to say, hey, match, if it is 1 or 2 or 3 or 4 or 5, any of these values, if they are equaling, then go and execute this statement. Else, if it is 6 or 7, 6, this pipe sign represents or. So either 6 or 7, any of these two values, then execute this thing. And if nothing of these above matches, this is again underscore indicating a default value. So you can easily use this multiple statement as well within the match statements. Okay, match with return value. You can use match with the return value as well. So in this case, just like if else, we can use the return value as well as an expression. So we can say if match execute once, then the return Monday. So what this means, that match day, when whatever the day is there, when it's evaluated, return that value and assign it to the value result. So you can use match as an expression as well. Okay, so each match branch must be the type same. So making sure all the values are exactly the same data type. You cannot use string and integer and float, mix and match the data types. That's not allowed. That's a big no-no. You have to have a same data type. And then these are all variable values. So when whatever the expression is matched, the variable's value will be assigned to this result variable, and then you can use that variable later on as well. Same as if else expressions, but in again using a match statements. Make sense? Perfect. Let's move on to the loops now. Okay, so Rust loops. Well, loops are execution blocks that basically repeat itself. It's what we call the code blocks that are supposed to repeat itself until a condition is satisfied. Unlike if else or match statement only execute once. Loops, again using the same logic, execute multiple times. Okay, so loop can execute a block of code as long as a specific condition is reached. Loops are handy because they save a huge amount of time, they reduce errors and make code more readable. For example, instead of writing the same line 10 times to print something, you can just use a loop to repeat itself. So Rust has three types of loops. One is itself called loop, then we have a while, then we have a for loop. Okay, so loop is the simplest Rust loops out of the three. It will run forever unless you tell it to stop. Meaning that if you write something, hey, loop, bracket stop, bracket close, print. So this basically means I want to repeat it all the time. So loop will automatically execute a block again and again and again and again and again. It has a built-in function, just it will cycle around itself. That's what loops does. Okay, so but this will become, in this case, this syntax will become a complete loop, means that it will loop forever because we have not told it to stop. We need to tell it to stop. Okay, so we need to be very careful with that as well. To stop a loop, we use a break statement. How does this work? Well, we say, hey, loop, break, print hello world, and then if count is equals to 3, break it. This is what a break statement does. We need to break the loop manually at a certain point. So what's happening now is, you see this hello world is printed 3 times. How does this work? Well, if you look at the code, what's happening now is that we say, hey, let mutable count is equals to 3. Mutable because we want the variable values to change. By default, again, remember, they are immutable. So we say, hey, make it mutable so we can change the variable of this count variable's value. Then we say loop it around and print the statement hello world. But we don't want to run forever. We need to make sure we are able to stop it, break it. To do that, we use a if condition statement. So if count is equals to 3, means that if the value of count becomes 3, block stop, block close, then what you need to do is you need to ensure that you break that statement. Okay, so what break does is it stops the execution flow. Okay, break keyword here is used to stop the flow. So it basically means that if the condition is satisfied, break the flow of the code and exit the loop. Okay, so and if you don't use it, the loop will continue forever. What break does is it stops the flow of execution for this particular loop. Okay, so break actually is connected with the loop itself. So as soon as you hit break, it just breaks the execution and comes out of the block of this code. Okay, so this is what basically it's trying to do. So now if you move up, return value. Now you can also return value from a loop, just like if else we explained earlier. Okay, using a break with a value. So let's see how this works. So for example, if you have a variable which is again mutable, so that we can change this value, we say let result is equals to loop. So now notice that what we've done is just like if else, loop is also now returning a value which will be assigned to here. But this return value now comes with the break statement. Okay, so when the count is equals to 3, break the loop, okay, and then return the value of count. Now this is again something that doesn't happen within Java or C Sharp. So if you are using it, you will notice that break just breaks the execution flow. You do not pass a value to the break, but in the Rust it is allowed. In Rust you can pass a value to break, and what it happens is that it will break the loop, returning the value of count or whatever variable you put here will basically be returned, and the result will be saved in this variable called result, or any other variable name for that matter. You can just change that. Okay, so the loop does prints hello until count reaches 3 and then stops, and then returns that number that hey, the loop stopped at this number. So if you execute the code, you would notice that it executes 3 times, prints hello 3 times, and then say the loop stopped at 3. So because we have used 3 here, so what if I stopped it at 5 and run the code again? Now notice that it prints hello 5 times. So this if determines how many times actually the loop is supposed to execute. After the condition is satisfied, it breaks the loop, returns a value of count, telling us that the loop actually ran for that number of time. Okay, and then that count variable is saved in this variable's value. Okay, so this variable value is actually saved here, which is again the result, or it can be any other name. Okay, so when you save the result for a loop into a variable, you must put a semicolon at the end. So you make sure you do put a semicolon at the end, so ensuring that it breaks, but at the same time notice there's a semicolon here as well. So in the example that we see this, there's a semicolon here indicating that this is an expression that would also end. The previous example, you notice there was no semicolon. So if the break doesn't return any value, there's no semicolon here. This is again a very common error that happens when you're doing Rust programming. You assume that there's no semicolon here, and if you return a value, it will generate an error. So if I return a count variable value here without using a semicolon, this basically means it's an expression and it's not ending. But because we are returning a value, we have to receive a value here as well. Okay, so because we are not receiving a value here, this again generates an error. At the same time, there's no semicolon here, this again generates an error. So it's all a complete error statement just because we are not using it. So do make sure that when you are using a return, there are 2 standard rules. Okay, the first rule being that you have to receive a value, and then the second rule is you need a semicolon here. Okay, that's one thing that you have to keep in mind. Now let's talk more about while loops. Well, the while loop runs as long as, again, the condition is true, similar to the standard loop. But this time, the condition we specify is within the while loop. And this is why it's one of the most commonly used loops throughout the programming. The syntax is almost same. So what we do now is, again, we declare a variable, making sure it's mutable, so the value changes. Then we use while count is less than equals to 5. Bracket start, bracket close means the block start, block close. Then we print exclamation mark as a, and then count variable's value is printed here. Okay, then count plus equals to 1. Well, this basically means that change the value of count, okay, by 1. It's like an increment operator. It changes the value of count to 1, and then every time the loop executes, it changes the value of 1, checks the condition, and prints the statement. So if you execute the code, again we have function main, bracket start, bracket close. Then inside it we declare a variable starting from 1. Then we check the condition. Hey, count is less than 5. So initially it's 1. Yeah, condition becomes true. It prints the value here. Okay, how it prints? It uses count, colon, and then again expression, bracket start, bracket close, and then the value of count goes here. Then what we do is we do the increment, by meaning we change the value of count. So we say count plus equals to 1. This means, hey, add 1 to the value of count. So now count becomes 2. And the next time when the loop executes, it says now count, which is 2 this time is less than 5. Again, condition becomes 5, then 3, then 4, then 5. And when the condition becomes false, it just stops. So this makes it much more simpler and easier to use as compared to the standard loop that we just discussed. Okay, that's why it's one of the most commonly used loops in programming as well as in Rust. So if you're in Rust, you will find that most people tend to still prefer while, because it's much easier to handle and you don't have to worry about the break statements and everything. Okay, so in this example, the loop keeps running as long as the counter is equal or less than 5. Okay, now the false condition. The while loop checks the condition before each loop. So if a condition is false at the start, the loop will not run at all. So for example, if the value of count is 10 and you say, hey, count is less than 5, what happens here is that it's called a false condition. The loop breaks and does not execute at all. Remember, this condition returns true or false. So if it is false, it will not execute at all, and then nothing will execute, just like if statements. So the condition determines whether the loop executes or not. The condition also determines how many times the loop is supposed to execute. Based on that, the loop statements are repeatedly cycled around. Okay, stopping a while loop. You can use a break inside a while loop as well, given a certain conditions, just like we did in the loop standard statements. Okay, so you can very easily say, hey, if num is equals to 6, break it. This statement will again work perfectly fine, no problem with that, just like in the previous loop statements. So you can easily break the statement as well. Okay, skipping a value. You can skip a value by using a continue statement. Now, break and continue, again, break are similar to each other, but break actually breaks the execution flow and continue skips the flow. Okay, so we use a continue statement to skip a beat, So if I execute the code to explain what's happening here is, now you would see that I have a let mutable number 1 while num is less than 10 if num is less than 6. So first we are checking, hey, number value is less than 10, execute it until 10, starting from 1, execute until 10, print the value of num, whatever is the value here, print on the output, and then add 1 to 1. Add 1 to the number value. So as long as it starts to work with it, it will add 1 to it, 1, 2, 3, 4, 5. But at a certain spot, we say, hey, if num becomes 6, for some reason we want to skip this beat. So now what happens is that if the value of num is 6, num plus 1, do the increment. So we are ensuring that it does the increment. However, we are using continue. What continue does that instead of breaking, just like a break statement, it just goes back to the main loop statement. Okay, so from here the control moves back to the while and it skips the remaining statements. Okay, so it will execute. So in other words, it doesn't stop the execution flow. It just skips the rest of the statements from that point forward. So when you use continue, anything after this is actually skipped. So the statements before it are executed, but as soon as it reaches to the continue point, it skips the rest of the statements and control goes back to the loop. That way, these two statements are not executed. So you will notice that there's no number 6 here. So number 6 is not printed, even though it is generating number 6. Okay, so number 6 is there, but it just skips and doesn't execute or does whatever task we wanted to do after the certain statements. And that's why we needed an increment statement here to ensure that it keeps on going till the next statement. Because if you don't do increment here, every single time it can just get stuck in the loop. So for example, if I just comment this loop out, okay, so now this is commented out. And then if we stop the, oh, sorry, not this one, not this one, no, this one, bring it here and then just comment this line out. So now what happens is that when num value becomes 6, num less than equal to 10, condition becomes true. It comes here, num is equals to 6. It says yes, num is less than equal to 6. Sorry, num is equal to 6, and then it continues. So continue means that it will go back up to this point and it will not execute this line. But next time when it executes, the value of num is still 6 because we have not done the increment. So this will make it the loop in a continuous infinite form. And it will continue to print 555, or they will just continue to stuck here and the loop will go forever because we are not changing the value here. So this becomes quite important statement that you put this value here. Make sense? Good. Okay. So now moving forward, let's check about for loop. Well, similar to loop and while loop, for loop again does exactly the same thing. It loops a statement. However, the syntax varies a little bit. So when you know exactly how many times you want a loop to go through a block of code, we use a for loop together with the in keyword. Now, in keyword is commonly used in Python as well. So if you're coming from Python to Rust, you might be familiar with the in loop. But in Rust, we have something called for. I becomes the variable, and then we use the in variable. Okay. So if you check the code, What we're doing now is, see this, it's the syntax becomes even much more simpler. We use function, we say for I in 1 dot dot 6. What this now is doing is, it's doing multiple things at the same time. Okay, so this one line is actually doing multiple things at the same line, and then it's printing the value of I. Now notice that there's no initialization here. We have not initialized the variable, just like in previous examples we did a mutable variable initialization, so we can do the increment. Second, there is no increment statement here as well. And like if while loop, we had to do an increment statements, or the loop will run forever. So we have to ensure that the variable's value changes over time, so that at a certain point the condition becomes false. However, if you use for loop, see this, you can give increment statement depending on how you actually using it. But in this example specifically, there's no need for increment statement, because the for in loop is doing multiple things automatically. Third, notice the range. Okay, 1 dot dot 6 is actually specifying a range of numbers we want to print from 1 to 6, where 6 being an exclusive number. So it basically means start from 1 and go less than 6. And in Rust, you can just simply use dot dot operators to specify a range of values. So here what we're technically doing is we're saying, hey, listen, let me just zoom into this guy a little bit so we get a better view. That's better. Okay, so we're saying, hey, listen, go inside the for loop. I becomes an independent variable. Currently, it's not initialized, doesn't have any value. But then when we use in basically means that go from 1 to 6, take the first value, assign it to the variable I, print that variable I, go back here, find the next value in this range, assign it to the I, overriding the previous value, so it becomes immutable automatically, and then print the value of I. Go back again here, find the next value in the range, assign it, overriding the previous value of I, and then print the value of I here. So automatically when you use in keyword with the for loop, you are traversing through a range. You can traverse through an array, you can traverse through lists. So you are traversing through certain items automatically, reading each item one by one, assigning it to the value of I, and then at the same time also evaluating a condition. Is there any next item in the list? So here when we use 6, 6 is exclusive, means less than 6. So you notice that it prints only up till 5, not up till 6, because the number 6 is exclusive. So this automatically starts from 1, assigns it here, prints it, goes back here and said, hey, because this is a range, find me the next item in the list. So it becomes 2, 2 is assigned to the I, 3, 4, 5, and then up till 6, it checks the condition. Hey, I'm supposed to stop here. So in keyword is also checking the condition. Is there any next item there or not? So using this single line, you are actually doing multiple things. You're initializing a variable, assigning it a value, looping through the items in the range, checking the condition, and then just iterating the loop directly. So make sense? Yeah. So that's why it's more wonderfully used in future scenarios. Okay. So this prints number 1 to 5. Note means 1 up to, but not including 6. So x6 is actually excluding number. The Rust handles the counter variable I automatically. Unlike many of the programming languages, you don't need to declare or increment it manually. Okay, so in other languages, if you're using Java or C Sharp, you would have to actually declare I variable, initialize it with 0. But in Rust, you just use the variable and Rust handles this variable, in this case, automatically. Okay, inclusive range. If you want to ensure that it also includes 6, we use an equal sign. So it's just like less than equal to 6. By using a dot dot, we're specifying a range. And then by using equal to, we are telling it, hey, make sure it goes up till 6, including this number as well. So making sure by using this equal to, we are telling it that, hey, I want this number to be inclusive. By default, as I said, it's an exclusive, it will go less than. But using this will basically change the condition and make sure it will go up till that point, including that particular number, hence becomes inclusive range. Break and continue. Since we have already discussed this, yes, you can use break and continue inside the for loop as well. So just like other loops, you can use breaks to stop the loop and continue to or skip a value. So you can say, hey, continue basically means that if I reach to this point, skip all these statements after this block and go back to the loop. So this is going to skip the value 3. And at the same time, we say, hey, if it reaches to 5, even though we have given a range, just break the statement. So within a certain condition, if the user matches or the value matches, just break there. So we can say, hey, iterate through 200 items or 10,000 items. But as soon as you find this item, just break it out. So for searching purpose, we can iterate through long lists and long data. And then once we found the data, there's no longer no point of finding the remaining values because we have already found it. Okay. and then that's why the break statement is there. So you can use continue and break with this thing as well. Make sense? So here's a quick summary of all three types of loops that we use inside Rust. Loop, simple loop is the simplest kind of a loop. It runs forever unless you manually specify a break statement. While, well, it has a predefined condition already with the syntax. So we say, hey, while count less than equal to variable, and then it prints it. But here we have to ensure we do increment as well. In that way, we will ensure that the value of count changes, and at a certain point, the condition is satisfied. Otherwise, again, infinite loop, it will run forever. Similarly, for loop, again, a very powerful loop. It repeats itself with a fixed number of times, always using a range variables, or you can change these parameters for other things as well. Okay, and then we've talked about break and continue as well. So that sums up the whole looping thing. Now, finally, let's talk more about functions inside the Rust before we close the session. Now, what do we mean by functions? Well, function is a block of code that runs when you call it. Okay, it's a block of code that performs a specific task. Just like main function we have been seeing, main is also a function. But this is a default function that you need to start the program. So every Rust program has to start with the main function. But you can create your own custom functions as well. So functions are considered as a block of code that perform a specific task or specific instructions, like adding, subtracting, reading file. So there can be a multitude of functions that perform. Second major advantage of function is repetitive code. So you can use functions to perform repetitive tasks that you want to perform again and again. Okay, so that's why we say, so we use functions for organization purpose, and we use it for repeating your code. Okay, rather than writing something again and again, using a function can allow us to repeat our or rewrite or reuse our code again and again, making sure your program is easy to understand as well. So how do we create functions in Rust? Well, creating a function Rust is quite simple and easy. We have already talked about it. You need to use fun, fn keyword, just like in other thing, just like in main function. We specify this prefix, letting our Rust compiler know that, hey, I'm using a function keyword followed by the function name. In previous examples, we have used the main. Here, we're going to say, hey, function, and this is going to be my own custom function, block start, block code. And anything you can write here from all of these topics, any standard Rust function or Rust code basically goes here. This will basically be our own custom function. Okay, but how do we use it? We call a function. So this is also called function declaration. We declare a function, and then we talk about something called function calling. Function calling means that we call the function by its name using the parentheses. So here what we're saying is that, hey, I have a function. Oops. Here we're saying that, hey, I have a function, say hello, that prints hello function. So this becomes a block of code that performs a specific task. Okay, so this is a function that just prints a message, again doing a specific task. We use a function keyword, giving it our own name. Then this is called function declaration. Okay, then in order to use this function, we are calling it. Calling means we just this time use the function name with the round parentheses. So we're just using the same function name with the round parentheses. It calls a function. Okay, then the function can also take parameters. Okay, by parameters means passing specific information to the parameter or to the function. So you can send information into the function using these parameters. Parameters are written inside these round parentheses. The way we write it, we provide a variable name, colon, and the data type. So dollar and str. This becomes this type of data this variable is supposed to receive. So when we say print hello world, now we use this variable name, same as we provided here. But this time, remember, see, we colon str. And if you remember from previous variables and data types topic, this is how we explicitly define a variable type in Rust. So we are explicitly telling it, hey, I have a variable colon and str. It's supposed to be string. Then when we call the function using the same function name, we provide a string argument to it. So if you check out the code, you will notice that we have a function main. It contains our default function, which is again another function declaration. So we're declaring a function inside our main function, and then we use a greet John. So what we're happening now is we're calling this function. Now, if you are coming from Java or C or C#, you will notice that in those languages, you cannot declare a function inside a function. You cannot declare a function inside a function. However, in Rust, you can declare a function inside another function. Make sense? A little bit. Okay. So basically what's happening is that we already have a main function, And inside this main function, we have declared our own function and we have called our own function. This happens here. So this is a function, greet, and then we have called the function. We have provided a parameter, and then we use the same parameter here. This becomes a variable name of type string. We use the same variable here to print the variable value here. Okay, function usually do return a value as well. By return a value means that when we call a function, we want it to perform a specific task. But when a task is performed, after the task has been performed, we want to receive an answer. We want to receive some form of reply. And that reply is known as a return values or return type. So a function can do that using what we call an arrow symbol. In this, so we basically use the arrow symbol in the function header to show that what type of value will be returned. Inside the function, we use the return keyword to send the value back. Okay, so let me explain how it works. So basically, again, we have a function. This time we're doing add, just does a simple calculation. We declare a variable a, colon I32, its data type. Again, data types we have discussed in previous session. B, colon I32. So we're defining an integer of 32 bytes. So we declare a variable a and we declare a variable b. Again, we can declare as many variables as we want using a comma separated value. But because it is going to return an answer to us, because we want it to perform a mathematical addition, so we use an arrow function, arrow I32. This indicates that this will return an integer number. Again, I32 represents an integer value. So arrow indicates, hey, this function, when it's executing, this will return a value. And then inside the body, we use a return keyword. And then whatever calculation or variable or data you want to pass here. So you can save this information and return a value. So this means that whenever we execute this function, we need to provide it two arguments, comma separated. Both have to be of type integer. When they execute, this will give us an answer. And then in order to ensure that the answer is actually returned, we use a return keyword with the value. Okay, in this case, a plus b. So we take the value of a, we take the value of b and add it. So this becomes my function declaration. Function calling, on the other hand, we use add. Again, we call the same function name here. We provided two arguments, 3 and 4, because we again need two arguments here. If you pass only one argument, it's going to complain, give an error. Hey, this function needs two arguments. You're only giving me one. So make sure you do give it two arguments based on the function declaration. So declaration is like a syntax defining what this function is going to be and what it needs in order to perform the tasks. So we say, hey, I need two arguments here. Once two arguments are passed, this function will perform its task. But because we have used an arrow function in defining that this will return an integer number, and we have used a return keyword ensuring that the value is actually returned, this function, when we call it, will return a value. So it's like we are calling a function, we passing it a value, and now we are expecting an answer. Because we are expecting an answer, we have to ensure that we receive that answer at the calling point as well. The declaration indicates that when you pass it a value, it's going to perform some calculation on it and then give you answer back. Because it's going to give us answer back, we have to receive the answer as well. So if you don't write this statement, in previous examples we didn't, because they were not returning anything. Here it is returning something. So because it's returning an answer to me, we have to receive the answer as well. If you don't, it's going to complain, give us error. So what we're now doing is we're saying, hey, add 3 plus 4, whatever is answer returned from here, assign it to the variable sum. And then we can print the value of sum here. Let's look at the code. There you go. So now you see sum is 7. So whatever values you pass here will actually be added up together, and then it will perform this task. So this becomes our reusable code. We can now pass it and call this function as many times as we want. So for example, I can just copy this code, Control C, come back here, Control V, Control V, Control V. So for example, I've passed it a couple of times. Let me just change the value here. So for example, 3, 4, 5 and 57, for example 67. So this I've called it 4 different times, but I'm using the same function. That's why the reusability comes into play. So you write the actual logic only once, and then all you have to do is call this function again and again and again and again. Every time you call, it will perform the same task. So it performs a specific task, same task again and again as many times as you want. So you just need to call it. But remembering, every time we call it, it will perform the task, return a value to us of type integer. So if you use another data type here explicitly, it might just complain because, hey, it's returning an integer data type here. So we just need to do casting. So make sense? Perfect. Okay. There we go. This is functions. So I hope you understand all of these concepts, and hopefully this should be much more easier to follow. Okay. So in Rust, you can omit the return keyword, just write the value on the last line function without the semicolon. This would also return a value for us. So if I execute the code, see this, we still get an answer. So you actually don't need to use the word return again and again, but because this word is commonly used in other programming languages as well, like C, Java, and C++, C sharp. So that's why it's also there in the Rust, but it's not mandatory. You can just simply use return, but because we are not using a return keyword, there's no semicolon needed here as well, indicating this is like a continuous expression. Okay, just similar as if else, when we use if else for a return type as well, or loops, we return a type. Remember, at that point we use a semicolon. So in this case, this syntax, there is no semicolon. This can get confusing to a certain point as well. So usually you would find that most standard programmers tend to use return a plus b with a semicolon. That way you follow a standard syntax and don't have to worry about, hey, where the semicolon goes and where the semicolon doesn't go. Okay, so we use return a plus b. Okay, but there's an option, you can skip the a return value, but if you do that, don't use the semicolon here. Okay, make sense? Wonderful. Okay, so that concludes our session today. Hopefully you have learned plenty of things about Rust and as much basics as you can. Okay, so, and just like that, we have conquered the basics of Rust. I know we have covered a lot in a very short amount of time, but now you have a solid foundation to build on. Remember, this is just the beginning. The next steps are all about practice. I highly recommend you go back to the W3Schools Rust tutorial and re-explore some of the topics we have touched on, and try writing your own small programs and experiments with the concept we have learned. If you enjoyed this tutorial and want to keep learning with me, be sure to hit that subscribe button and ring the notification bell so you don't miss out on our next videos. We have got a ton of content coming your way. Thanks for watching, and I will see you in the next video. Happy coding.